Welcome everyone who have shown the interest on my topic, the oversights under the flow. And in the last year, I just discovered and try to find some vulnerabilities on the machine learning operations, the tooling suites, and related open source softwares, and especially for some big companies such as the Azure and Microsoft. And I have found some small findings, and will share the experience and the progress on my searching or the research progress on this kind of the results. And the topic is the oversight under the flow, because most of the vulnerabilities I have discovered during my research, and I found the vulnerability is very simple and easy to disclose by maybe everyone you sitting here. But the oversights may always repeated on the same software tech stacks, etc. Because maybe not every software developers are the experts on the security, and they are from the broader scope of the machine learning communities, because they are focused or concentrated on how to make their machine learning or machine learning related softwares working effectively and efficiently, not just for the security issues. But if most of them do not care about the security, the outputted software may contain some vulnerabilities may at the first glance, the vulnerability may not make a very big impact. But if we do not care about them in some programs or some other following in the software supply chain development, a tiny bug may become very big impacts in the future. Okay, so I will show some of the experience on my research here. And I'm from Shanghai University, and I'm also interested on auditing some open source softwares, because the codes are open, and if you have more interest to my background, you can look at my GitHub's homepage for some details. And the agenda for today's talk, I have 5 parts, and in the first 2 parts, I will introduce some simple backgrounds of what is the Azure machine learning operations, and also what is the tooling suites. We focus on the Azure machine learning operations, and what is the evolving progress from the DevOps to the machine learning ops, etc. And then the third part, I will introduce the vulnerabilities I discovered from the tooling suites integrated into the Azure machine learning operations. And also, I will discover more scope the code base of this tooling suites, and identify what is the secure solution. Mostly, in most cases, are already in the code base, but the developers or the following contributors overlook to apply them. And also, despite this kind of the tooling suites are maintained by the Microsoft staffs, but the contributors may not are all from them. They are from a broader scope of the machine learning communities and the software contributors from the GitHub and etc. And also, I will discuss some impacts of the vulnerabilities. Maybe at the first glance, the impacts are not very big, but when we dig or search some new tricks, we can make a tiny vulnerability to make some bigger impacts than we ever expect. And also, when I reported these vulnerabilities to the MSRC, I can also find the overlook. The oversights also exists during the coordinated disclosure progress. That means I report the vulnerabilities, and the MSRC asks the maintainers to patch or fix this kind of vulnerabilities, but they ignore and some patches, or also they take the security as a very important aspect to launch the fix. But during their fix, the fix is not complete, and also make some interesting observations from my perspective. And at the end, I will discuss with you some potential countermeasure for this kind of the oversight. Maybe it is impossible to completely solve this kind of the problems because we cannot ensure all the humans do not make the errors or the overlooks during their daily works. And but we will discuss whether we can ask the large language models to do some help and to reduce this kind of the risks induced by the oversights. And also at the end, I will finalize my talk with 3 takeaways. Okay, and the first item is for the flow for the Azure machine learning operations. Before we can talk the machine learning operations, I will first talk the DevOps. It is a very important concept in the traditional software development progress. And it covers from the software plan or design phase to the coding and the testing, and then for the releasing and the deployment on the production environments. And finally, to when the software is released to the end customers, and we can also monitor the customers' feedbacks to continuously refine the progress of the software development progress. So we call them the DevOps. But for the Microsoft's technical stakes, the Azure has their own tooling suites and some softwares running on the clouds to support this kind of the DevOps. We call them the Azure DevOps. And from the Azure, from the DevOps to the machine learning operations, it is due to the rise of the large language models and the machine learning and artificial intelligence techniques. Because all of these techniques evolve significantly in recent years. And then there are many traditional softwares are involved from just software with enabled by the large language models capabilities to enhance the customers' experience and their usage efficiency and effectiveness. And by these requirements, we should introduce the machine learning model phase onto the software development progress. We call them the machine learning development progress. And as you can see in this figure, and in addition to the traditional DevOps, we add an additional component we call the machine learning component into the DevOps. So we call this kind of new concept as the machine learning operations. And for the machine learning operations, we should introduce maybe a parallel or the simultaneously development progress for the machine learning models, similar as the software development progress. And if we look into more details, it may be divided into 4 phases for the machine learning development progress. They are the model training, and then testing, and then evaluation against a bigger data set to ensure the capabilities of the machine learning models, and then the synthesis to release for the customer's usage at the end. And to support this kind of the machine learning operation or machine learning development progress, the Microsoft Azure also released a suite of the tooling suites to support this kind of the new requirements. And if we have a global view on the Azure artificial intelligence and the machine learning architecture, and you can log into your Azure account, and you can use we call them the Azure machine learning workspace for your development. Also, it also supports for your development on your on-premise networks, on your local machines, etc., and use the tooling suites running on the client side or on the clouds to support this kind of the development. And the purpose for the Azure machine learning workspace is to facilitate the development of the machine learning enabled Azure applications to enable the large language models to support the Azure apps and serve the end customers. And as there are tens of more than 20 tooling suites, the Azure stack. I will just present the 6 tooling suites because I can find the oversights cost vulnerabilities for them. And from the traditional Azure clients and the Azure devs to the cutting edge, we call the PromptFlow. And the Azure-AI-Generative is a part of the Azure's patient stakes SDK. And also the DeepSpeed for the training phase. And also the TorchGeo is maybe not for the machine learning operations, but it shows a very interesting case how the oversight happens. So I include to report it here. And for the machine learning operations, maybe we can just read it as the machine learning plus the DevOps. And this is for handling the training, testing, evaluation, and the synthesis. And also you can handle them from your on-premise networks in your local machines. And simultaneously, maybe you can handle them from the on-cloud Azure machine learning workspace, AI workspace, etc. And the tooling suites are working on different tooling suites working on different phases on the machine learning operations. And I just divided them, maybe not much accurate. And anyway, the oversights, the vulnerabilities, and the impacts. The first oversights, I will report it from the PromptFlow. Maybe it is on the rise of the more and more users to follow, because if you use the VS Code, and you may enable the PromptFlow in your Visual Studio Code, etc. And if you design the Azure applications on the cloud in the Azure machine learning workspace, you can also enable the PromptFlow to facilitate your development progress. And its main purpose for the PromptFlow is to build high-quality large language model applications from the prototyping and testing to production development and monitoring. And it has the graph design. So if you have not a strong background for software development, you can also get familiar for this kind of design very quickly. And this is an example in the Azure Machine Learning Workplace. If you try to enable to deploy some PromptFlow in this workspace, and the core and currently it considered as a core feature for the Azure Machine Learning Studio and a tool for the Azure Machine Learning operations. And the first oversight I find is a very, very tiny vulnerability. We call it the command or the code injection. And you can see the code is use the join function to convert the list back into the string. And as the code enables the shared, set the shared to true. That means the command injection can be injected by the common or some AND operations to make the malicious behaviors by the arguments. But if we look the code base for the PromptFlow, we can find there are so many secure cases for this kind of to prevent this kind of the command injection. And for example, to specify the port parameter to the integer type, and then do not set the share to the true value, and also use the list as the parameter rather than the string. And if we go some in-depth techniques of the code path, how the attackers can input their malicious parameters to make the command injection happen, we can find maybe they can the code path, the source of the code path may go up to the PF PromptFlow client. That means if the attackers can control the PromptFlow client as the command line input, and then he can get at least the privilege escalation by this kind of the command injection. But if we look at the not from the PromptFlow client, but look at the function name for this command injection, we can find it related to the start experiments function to get the parameter as the inputs. And so if the victims are the Azure application developers, and they want to use this kind of the prompt flow to develop or produce some Azure applications. They may use the start experiments function in their code, and then induce this kind of the code injection in their Azure applications. So we call this kind of the vulnerability affecting the experimentation for the machine learning operations. And this is the POC, and of course this POC is very simple. And because in the attack step, we can just consider the attacker can just run the command pf flow in the terminal, and then can introduce the vulnerability like this way. But if the victims run the experiments.start function in their all Azure applications and expose it to, for example, to some REST APIs, etc., it can introduce this kind of the local vulnerability to a remote one. And this is a vulnerable flow. The demo of the vulnerable flow I will show you in the Azure. And because if you design the software in the Azure, you can just use their graphs and to introduce some inputs from the large language models, for example, from the Microsoft's Azure, OpenAI, etc. And then, like this way, if the input is exposed to the end users or to the adversaries, and then they can just insert the malicious commands to make this kind of the attack realistic. And the second vulnerable code I will show you is a very simple path traversal. But this path traversal, you can see here, it just uses the string concatenation to make the directory and the file name with the extension name to rebuild the file name, the file location to write some we call the image data. But if we look into the code base, we can find the maintainers of the PromptFlow understand they should use the safe join function to get this kind of the concatenation. But they overlook here. Maybe they consider the file name is just the hash object, and the directory, they just use the path to control it. So they ignore the extension name in this case. And at the following code, we can find they just use the file path with the extension name and to write something in the local disk and make this vulnerability possible. And if we look at the vulnerable code path, we can find this exports the path traversal to API endpoints at the PromptFlow. But the maintainers of the PromptFlow do not consider it is a remote vulnerability because they set the default listening interface is on the local host. I will discuss the details later. And by this way, you can see this GIF demonstration. If the victims launch the PromptFlow service at the backend during their development progress, and the attackers can just use this kind of the HTTP request to, in this example, I just write a malicious dynamic link library in the system13.2 directory in the victim's local machines. And this is a debate on what is the local vulnerability or remote vulnerability, because by default, the PromptFlow can only listen on their local host. We call it the local host or the 127.0.0.1. But there are some customers ask the question for the PromptFlow's maintainers on the GitHub, you can see some customers need the PromptFlow's service can listen on the 0.0.0 point. That means on the maybe the local host and on the public host. And of course, the maintainers of the PromptFlow acknowledge this requirement and enable this kind of the function in their latest release of the PromptFlow. And so by this way, we do not just consider this is a local vulnerability, because some victims may use the PromptFlow's service to listen on the not just restricted to the local host. And another way we can check this so-called local vulnerability to a remote one, we can find the Snake's blog. But I think it is a more general case that we can make this kind of the local vulnerability to a remote one. Because even you listen on your local host, but you are the software developers, and during your development progress, we cannot make sure you do not serve on the internet. In that case, if you open some third-party websites or click some links, in that case, the attackers can just make the attack payloads writing in some JavaScript and make the upload possible from the 0-click local to 1-click remote. And I just asked the GitHub cooperator with the GPT-4o to write a POC to escalate from the 0-click arbitrary file upload vulnerability to 1-click vulnerability from the local to the remote. And okay, the second one I will discuss with you are the client-side SDK for the Azure AI Studio. Its main purpose is for building, evaluating, and deploying the generative AI applications that leverage the Azure AI service in the Azure AI and Machine Learning Studio. And this is the first vulnerable code. It happens that means the Azure AI-Generative, the maintainers use the evaluation. It's very simple bug to evaluate the stop code and the stop token in their code. And but if we look at the code base, we can find the this kind of the maintainers frequently use the literally evil function rather than the evil function directly. They are the safe case. And if we look into the code path to this oversights, we can find the vulnerable code can go up to the OpenAI complication model in this kind of the Python SDK. That means if the Azure customers use the Python SDK to develop their own Azure applications, and they use the OpenAI completion model function and expose it to the some API RESTful endpoints, and it may introduce the vulnerability in their own Azure applications. And there are more similar cases, but I will show you later, because when I find the first case of the the use of the unsafe evil, the other three cases are not exist. But during the patching progress of the Microsoft's maintainers, and they patch the unsafe evil I reported, but introduce new unsafe evil at the same time. And this is the code path. I will not dig into some more details here. And it is just affecting the evaluation based on my analysis on the name of the function. And also, this is a very simple POC, but if we should make the vulnerability more impacts, the victims should use this kind of the Python SDK to write their own Azure applications. And This is the demo for the vulnerable flow in the Azure when the customers write their own Azure applications on the clouds, etc. And the third one is from the DeepSpeed. It is mainly for the model training and optimization library that makes the distributed training and interface easy, efficient, and effective. And the development code is still very simple. It is a pin code deserialization vulnerability. And but it embedded into the distributed training progress for the DeepSpeed. And you can see the vulnerable code path, and then we can find, it is from the distributed training endpoint to receive some data, and just deserialize them to make the RCE possible. And if we look into here, we can find that this is a known problem by the PyTorch. And in the documentation of the PyTorch, it's clearly that we understand it is, may have some security risks, but we ignore to patch it. But for the DeepSpeed, they inherited it from the PyTorch. But in DeepSpeed's documentation, they do not tell the customers, the end users, this kind of the issue embedded. And the distributed computing is just for the computation happened between different GPUs and CPUs. And we call them, we can use them by the traditional Python's multiprocessing library, or also from kind of the collective communication library. For example, for the NVIDIA, we call the NCCL, and for the message passing interface, and for the UCCL, the Universal Collective Communication Library, etc. But at the hook, it just enables the communication, maybe through the sockets to enable the communication between the computing devices through the networks. And this is the multiprocessing package, and the Python, the native Python understands the risks and enable some secrets to give the baseline protection. But here, the PyTorch's distributed is differs to use the multiprocessing as the natives, Python's natives. And they just enable the network communication with the collective communication libraries without any security measures launched in between. And I just create a threat model in this kind of the vulnerability, because for the distributed training, some ranker, we call them the ranker 0, may be cooperated with the, for example, the rank 1. And due to the intensive training progress, because there are large data sets to learn and fine-tuning the model, the rank 1 device may get some latency to communicate with the rank 0. We cannot make the distributed training very paranoid. And in that case, the attackers can catch this time gap and place into to masquerade as the rank 1 and to communicate with the rank 0 and make the RCE possible. And here's the demo. How the attacker happens, and here I just mimic what is the attackers, what is the victims. We call the rank 0, and the attacker is rank 1, and the true rank 1 I ignore here. And you can see the attacker is very simple and make the RCE happens. And when I reported this to the MSRC, their response is considered as a low severity because they think it is calling the local host to the listening, and it will not expose to the public IP address. But the truth is that it depends on how the developers use this kind of the functionality. If they export the master port, the master port is okay. But export the glue socket IF name, that means the network card name. And if the network card is listening on the public, it can make the real RCE, not just in the local networks. And but maybe it is really to the victims really use the DeepSpeed like this way. But even the victims do not use the DeepSpeed like this way, unlikely to happen. We can also record a one-click trick. That means even the victims listen on the local environment, but we cannot guarantee every developers cannot access the internet, the public internet during their model training or something like this one, and them introduce the vulnerability happen in a remote manner. And for the remote POC, I will not have the time to write a POC here, but I have just give some idea. Maybe we should first reverse engineering how the MPI or the NCCL or the GRU, the package looks like, the structure of the package. And then we can use the WebSocket written by them in the JavaScript. And then we can craft some Pinko string at first and embed it into the JavaScript code, and then you can shift in your some domain under your control, and you can pitch to the victim developers to click your button, something like this one. And for the last oversight, the second last oversight I introduced is from the TorchGeo for the spatial data. Maybe this is not really from the machine learning operations, but also the vulnerability is very simple. It's just use the unsafe evil to the name. But the happening of this vulnerability is very interesting because the maintainers claims they just copy the code directly from the Torch vision maintained by the PyTorch. And they just copy the code. But if when I reported this kind of the vulnerability to the MSRC, and I found they are just copy from the Torch version, and I found the code in the same time of the Torch version. The Torch version do not have this kind of the vulnerability at that time. That means when the TorchGeo copy the code, the vulnerability exists in the Torch version. But afterwards, sometimes later, the Torch version patch this vulnerability by themselves. But the TorchGeo do not understand this kind of the upgrades. And then they just make the vulnerability still exist in the TorchGeo when I report it. And I can also find multiple command injections to the Azure clients and Azure devs. All of them are client-side softwares, and maybe make minimal impacts to the users. But the interesting thing is that for the Azure clients, the maintainers have a page in their documentation to specify mitigating security vulnerability when calling the system commands. And they just implement a safe sub-process commands. The API is the wrong command. And ask all the following contributors to use the wrong command rather than directly call the sub-process to introduce the security issues. But even they have comprehensively discussed this kind of the security issue, the following contributors still upgrade or contribute the new code using the sub-process and even have the valuable codes. Okay, this is the table I reported all of them to the MSRC. The interesting part is that maybe the perspective or the understanding of the impacts and the vulnerability are different compared between the MSRC and our reporters. Because for some vulnerabilities, I think they are more severity, but the MSRC do not believe it. But for some vulnerabilities, I think it is simple and not make quite severe impacts, but the MSRC MSRC consider them, they are important. And another very interesting thing is that for some reports, even they are important. And I reported for their cutting edges tooling space. For example, the DeepSpeed, not DeepSpeed. For example, the Azure-Generative SDK or the PromptFlow. They do not issue the CVE number for them. But for some tiny vulnerabilities, I think not deserve a CVE, but they issue the CVE for them. For example, the Azure clients and the TorchGeo, Geo, etc. So I think the Red Hat has a different perspective, and maybe we should follow the MSRC's understanding because they are the experts on their own softwares. And the oversights within the coordinated disclosure, I will show 3 case studies when I reported this kind of the vulnerabilities to the MSRC. The first one is that the Azure-AI-Generative Python SDKs. When I reported the first report for the evil, the use of the unsafe evil, they patched in the 1.0.0b9 version. But at the meantime, when they upgraded from, because I found the vulnerability in the B7 version, but in the B7 version, there are no the other the usage of the unsafe evils, but they induce the new unsafe evils in the B8 versions. But my report is on the B7. That means even I reported this kind of the vulnerabilities, they still introduce new vulnerabilities during the upgrade progress. And we call them, they just patch the synthesis, but not cover the evaluation part. And also the oversight tool is that for the Azure clients, I just report kinds of the sub-process issues, but they just patched on the service connector, but ignore to patch in the security issue. Even I send a follow-up email to report the unpatched security, they still overlooked at here. So I'm not quite sure whether they think in the security part, the vulnerability does not deserve to patch or they have some communication misunderstanding between the engineering team and the MSRC coordinated team. So this is the second oversight. And the third one is that for the DeepSpeed's command injection, when I first reported them, sorry. The first reporter is not me for the command injection. And after the first report vulnerabilities, the DeepSpeed launched a discussion in the GitHub. They just survey all the possible vulnerability entry points and go through all of them. I think this is a very good discussion. But even they patch all of them, they still ignore the -C can call back the command injection. And this makes the third oversight. And the even worse is that the -C is required by some feature requirements. So maybe there is a trade-off between the security and the functionality in this kind of the case. And for the countermeasure discussion, maybe we can, I just ask myself whether the large language models can do some help, and just send one example from the PromptFlow example to the GitHub Copilot and ask them to audit the code on behalf of the humans. And we find there are so many false positives and may not give some accurate patch suggestions based on the current LLM. And maybe if we should do some accurate detection and actually help the human beings, we should maybe find time or run some RAG or the oriented training for the large language models to do the help. And okay, at the end, the takeaways for the open source tool maintainers, I think they should apply some stricter security check for the new merge requests. Because there are a broader scope of the machine learning community contribute the codes. And for the MSRC, let me coordinate the disclosure progress in a more efficient and clear way. And for the Azure app developers, take care when you call the SDKs or the API functions from the even maintained by the Microsoft staff, something like this one. And thank you so much for your time to attend this talk. And do you have any questions? Oh, thank you.
Thanks, Prof. So I actually wanted to ask, I noticed in the first 3 findings that the insecure code versions were used in the...
You mean the first one?
Yes, I think first 3, the PromptFlow and path traversal. One was RCE, one was a path traversal. The code base that was being deployed on Azure is vulnerable. And then the code base that you found on GitHub was safe. Is that right?
You mean the path traversal?
Sure. The path traversal also.
Okay. And this is okay.
I was wondering why there was a discrepancy between what was pushed onto the GitHub versus what was eventually found on Azure. Did Microsoft mention what happened there between the discrepancies?
You mean the...
Yes, you said there's a vulnerable code path, and then subsequently, once you checked in the code base itself, that it was secure already. Is that correct?
Yes.
So this was found on... Was this found on GitHub or was this found on...
No, this is just for you can run a bomb, for example, the PromptFlow and launch the backend service.
Okay.
And when you do some software development, for example, you install the extension in your VS Code for the PromptFlow, and then you can run a command to open the PromptFlow service and backend, and then you can interact with the backend service, for example, do some files or something like this. But this maybe the original design is just for the local listening. So the default IP address is for the local host. And but as some developers in GitHub to ask, I need to listen on the, for example, the local networks or some more other requirements. So the PromptFlow enable a new function to enable the end users to change the IP address they can listen to. And by this way, they can listen to, for example, in my example, they can listen to some local network IP address. And also, if you listen on some public IP address, it can make the vulnerability can be deployed or rooted. Okay, in that way. And but I can understand that MSRC consider this kind of vulnerability as a low severity. By default, they are listening on the local host. My argument is that, my argument is that if we can read the blog published by the Snap, you can see every listening on the local host. We can make, because the upload just 0 click for the local. But if we can shift the payload in the JavaScript, and hold this kind of payload in some websites under the attacker's control, and then they pitch the victims to click the button, and in that way, they can also make the upload launched by this kind of JavaScript code.
Yep, understand. Sorry, actually it was on a different point, but never mind. I'll check in with you after again. Thank you.
Thank you. First of all, congratulations for the work. It's very, very interesting. Every time I come to Black Hat, I come back, I'm very disappointed and sad because this is terrible, right? So the bugs you have found, they are not super complicated to, to not do, right? Your work is great, right? But this is, if my students were writing code like that, I would fail them, right? So it's terrible. So I was wondering, since you have looked at the code a lot, do you think the overall code was produced by people who had very little experience and that would explain the problem? Or is it, no, it's well done code, but clearly they knew nothing about security, and the problem really comes with the fact that we do not teach security properly.
Yes, but I think maybe in all the code, some of the guys from the maintenance teams, they can understand the security and try to solve the security problems. But the more scope of the contributors, and they may not have the security in their mind. And even the Microsoft staffs handle the review tasks. They can always not continuously to pick up the maybe the errors, the updates during the progress. This may introduce the new vulnerability, I think.
Yeah.
I'm not quite clear whether
Yeah.
it is.
It's sad.
Maybe we do need some chatbots to have this kind of the task, because it is very boring. Maybe some security experts they are very busy and do not look at every tiny corners of the code base. And so
Yeah, but if you look at conferences like Black Hat and all the others that exist, DEF CON, Hack.lu, and all the others, where all these people like you, very competent people, the amount of time, of brain cycles we spent fixing things that should never have been there in the first place, if those companies had done the proper job. That is sad, because all these smart people like you could use their brains to do, better things for the planet, basically. So it's really sad.
yeah,
Sorry.
maybe there is software supply chain, and the others may use the others, calling the others APIs, something like this one, may make the security impacts. Thank you. And any other questions? Okay, if no questions, thank you so much for attending my topics, and thank you so much.